the Cretaceous rocks, the Cretaceous deposits in India are best developed in the Kaveri Basin, the Trichinopoly. You may find different names of Trichinopoly, spelling Tiruchirappalli, Trichinopoly, Trichinopalli. So all these, they are the same. So the Cretaceous formations of Trichinopalli, they are best exposed in Trichinopalli, and it's a very good area for the Cretaceous deposits. It's also called as Tiruchirappalli is also called as the Field Museum of Cretaceous deposits. Amazing place. I have been to Trichinopalli. I have done field work over there, and it's an amazing place as far as the Cretaceous deposits and their paleontology is concerned. In my lab also I have a lot of these fossils from this region. Okay, so let us begin. Cretaceous of Trichinopalli is best exposed in the Kaveri Basin. Let us have a look at the introduction to Cretaceous. The name Cretaceous has come from Creta, means chalk or limestone. Massive limestone deposits were formed during the Cretaceous period. Cretaceous is the last period of the Mesozoic era, and it is very important in terms of changing climate, changing oceanography, changing sea levels, and the major extinction event. One of the major extinction event is at the KT boundary. The name Cretaceous was given by D. Halloy in 1882, and he gave the name Cretaceous based on the dominant lithology, Creta or chalk or limestone. It is the last period of Mesozoic era and spans almost 80 million years. So the base of Cretaceous or the Jurassic Cretaceous boundary is at 145 million years, and the Cretaceous Tertiary boundary or Cretaceous Paleogene boundary is at 65 million years. So that spans almost 80 million years. Some of the important events during the Cretaceous period, they are very important in terms of the evolution of the earth. First one was the tectonic opening of the Indian Ocean. So if you recall the map of Gondwana, you will come to know that the Indian Ocean was not present before Cretaceous, because Indian Ocean, it uh, India was joined with Antarctica and Australia at that time before Cretaceous. So there was no chance for Indian Ocean. The tectonism, it led to the dismemberment of Gondwana land. It started to split apart. And if you remember the Jurassic period, the Jurassic period saw the movement between Africa and South America. They were together, and then rifting took place between Madagascar, India, Antarctica, and Australia. So it was one part, and South America and Africa was the other part. And they had started to open up. They started to rift apart during Jurassic, late Jurassic only. But during Cretaceous period, the Indian landmass started to separate from Antarctica and Australia. And this separation which was there, it also led to the, the Australia and Antarctica land masses were still joined together. So the dismemberment of Gondwana land, it started during the Cretaceous period. Then during the end of Cretaceous, a very important event took place. India separated and it started its journey towards Eurasia. We all are aware of that. So Indian landmass was the only landmass which traveled the maximum distance from its original location to its present location. Then two igneous activities took place. One close to 120 million years, that was the Rajmahal igneous activity, the Rajmahal igneous deposits which were the bedded basalts, and close to 65 million years the Deccan igneous activity. So the Rajmahal traps and the Deccan traps, they both are Cretaceous. The end Cretaceous, it saw an important extinction event which marks the Cretaceous Paleogene boundary, commonly referred to as the KT boundary. And in the so two major events. In the terrestrial realm, all the dinosaurs disappeared. Dinosaurs got extinct. You will not find the record of dinosaur anywhere in the world beyond Cretaceous. And in the marine realm, in the invertebrate fossils, all the ammonoids became extinct. These are two very important characteristics of end Cretaceous, the KT boundary event. Okay, and you can also now guess that the radiation or proliferation of smaller mammals after Cretaceous period it started. So after the Cretaceous period, the mammals and small terrestrial animals, you know, they evolved. And one very common reason for this evolution can be given to be the extinction of dinosaurs. Imagine if dinosaurs were there, would they have allowed the smaller mammals to proliferate? No, they would have eaten them up. Okay. So this KT extinction event was a very important event which led to the proliferation of the larger vertebrates later on in during the Cenozoic. The Cretaceous period is divided into two epochs, and now they are sometimes in the recent time scale they are also called as sub period. They are the early and late epochs, early and late, and once we are calling them the Cretaceous system, then it will be lower Cretaceous series and upper Cretaceous series. So the early Cretaceous epoch or sub period is further divided into six of these stages. And these stages, six are there in the early Cretaceous and six are there in the late Cretaceous. So these 12 stages for entire Cretaceous, their boundaries was defined on the basis of ammonoids in France and Netherlands. So boundary of the 12 stages, how has it been defined? It has been defined on the basis of ammonoids. Okay. So the first stage of Cretaceous is Beriacian. Beriacian ranges from 145 to 139.8 or approximately 140 million years. And you should remember this. How is Beriacian defined? First occurrence of the ammonoid Beriacella jacobi. This is Beriacella jacobi. It is an ammonoid. Okay. If you look at this shell, how fine ornamentations are present over here, and it was kind of a loosely coiled shell. Okay, slightly loosely coiled shell. I'll tell you, I hope you all know what is the meaning of loosely coiled shell if you have seen my video on cephalopoda. Next, after Beriacian came Valanginian. Valanginian ranged from 139.8 to 133 million years, followed by Hotrevian. Hotrevian was defined on the basis of first occurrence of Anthodiscus. Again, a loosely coiled ammonoid. When I say loosely coiled, you can see here that in these shells, you can see this is first whorl, this is second world, this is third world. Means you can count how many times did this ammonoid coil, did the shell coil. So that is called, when when you can see that, this is called as the loosely coiled shell. So Anthodiscus, it is a loosely coiled shell, but Berriasella jacobi seems to be slightly tightly coiled than Anthodiscus. After Hauterivian comes Barremian, 129.4 to 125 million years, and the first occurrence of Spithydiscus hugi and Spithydiscus van Dyckii. These are two ammonoids. Again, they are loosely coiled. You can see the entire coiling of these ammonoids. See, this is how they have coiled. So this is Spithydiscus. So don't remember the name of species, just remember the name of genus Spithydiscus. So Barremian has been defined on the basis of first occurrence of the ammonoid Spithydiscus. Then comes Aptian and Albian. So early Cretaceous ranges from Berriasian to Albian, means 145 million years to 200.5 million years. Then comes the late Cretaceous. Late Cretaceous, it ranges from 100.5 to 66 million years approximately. Now, the first stage or the basal stage of late Cretaceous is Cenomanian. I see all these stages have also been defined on some of the paleomagnetic activities, but I haven't given you those names. I have given you the names of only those fossils which are used to define the stage boundaries. The Cenomanian is followed by Turonian, which is defined on the first occurrence of Vatinoceras. Vatinoceras, see, this is Vatinoceras, it is an ammonoid. Then after Turonian comes Coniacian. Coniacian is defined on the basis of first occurrence of Cremnoceramus rotundatus. It is a bivalve. It is an extinct bivalve, Pelecypoda. Then Santonian is Cladoceramus undulatoplicatus. This is another fossil, Cladoceramus undulatoplicatus. It defines Santonian. Campanian has been defined on the basis of last occurrence of Marsupitis testudinarius. It is a crinoid. Crinoid. So you can see the photograph over here. Now Maastrichtian, which is the last stage of the late Cretaceous subperiod or late Cretaceous epoch, it has been defined on the basis of two important events. The beginning of Maastrichtian or the base of Maastrichtian has been defined on the basis of first occurrence of Pachydiskis. Pachydiskis. So this the first occurrence of Pachydiskis, it tells that now you have come to the Campanian Maastrichtian boundary. But more importantly, the top of the Maastrichtian, which marks the Cretaceous Paleogene boundary or KT boundary, one of the most important proxies is the iridium anomaly. Now, those of you who must have studied chemistry must be aware that iridium is not found in indigenous form on the earth. It is an extraterrestrial element. It is not found on the earth. It is found in outer space. So how come the rocks at the Maastrichtian Paleogene boundary or the Cretaceous Tertiary boundary, they got iridium? What was the reason? And then below that, there is no iridium. Above that, there is no iridium in the rocks, in the sediments. So this iridium which was found in the rocks, it has been presumed and it has been defined that this presence of iridium in the Cretaceous top Cretaceous rocks or the Cretaceous Paleogene boundary rocks is that uh, at this juncture, at this point of time, some asteroid impact was there. And this asteroid which hit the earth, it became the reason for the end Cretaceous extinction. Apart from that, there are several important impact craters which were formed on the earth. In India, there is a very important crater in Maharashtra known as the Lonar Lake. Lonar Lake. It is an impact crater. Impact crater. What does that mean? Impact crater means that if this is the surface of the earth and a large asteroid or a outer space body hits the earth, it leads to the formation of a depression, a crater like this. So this crater, it is called as the impact crater. And later when this gets filled with water, it becomes a lake. Now, how do we know that a certain crater is an impact crater? If you'll go over here and look on the sides or the fringes of this crater, you will find very importantly a mineral which is called as shock quartz. There are two varieties of quartz, coesite and stishovite. These two are called as the high impact varieties of quartz, means they are formed from impact metamorphism. Impact metamorphism. What is the meaning of impact metamorphism? When a heavy body hits another substance with a great speed, it generates lot of heat, and that heat in the geological past was sufficient enough to cause metamorphism. That is called as shock metamorphism. So the shock quartz, if present anywhere, it helps us to know whether a certain area is impacted by the asteroid impact. And apart from this, then the iridium anomaly is there. So this is the basic definition of the Cretaceous and its stages. Okay. Now, an interesting thing over here, the large scale limestone deposits, they tell us that the climate during the Cretaceous period would have been warmer, and it has been found that the sea levels during Cretaceous were very high. If you see this sea level curve map and you try to mark out the Cretaceous period, specifically during the later part of Cretaceous, you can see that the sea levels were almost 250 meters higher than the present sea level. Present sea level. So you can imagine. So if you see this map of late Cretaceous, Turonian, see the sea level, it was almost 160 meters higher than present sea level. And see the condition of India. The entire northern part was under the sea. Whatever the part, only we can see only the peninsular part, and this portion of the Indian plate, it was all ocean, oceanic plate. It was all under the ocean. Now, if you compare the present day records uh, of the sea level, what do people say? That due to the global warming and other things, sea levels are rising. But if you compare the Cretaceous period sea levels, they were almost 250 meters more than what there is, what it is there today. Now, this is a representative of the fluctuations in the sea level due to the changing paleogeography as well as the climate. So you should know that during the Cretaceous period, the sea levels were very, very high. The important fossil groups that came into existence during this period. So in the microfossils, there were several foraminifera, which is the first photograph which you see over here. Foraminifera. I'll not bother you with the names of these. Then there were coccolithophores, or what we say as calcareous nanoplanktons. So these were all photosynthetic calcareous test-bearing algae, haptophyta. Then dinoflagellates. These are the dinoflagellate shells. And then siliceous microfossils, radiolaria. These were the very important microfossil groups. The invertebrates, echinoids were very common. So if you'll go to the Ariyalur region of the Tiruchirappalli, you will find lot of these echinoid fossils. You will find Stigmatopygus, Micraster, Hemiaster, Orthosidaris, lot of these forms. Corals, bivalves, gastropods, and ammonoids. So obviously, so all these were very, very important organisms that used to live during the Cretaceous period. Vertebrates, they had a lot of fish, amphibians, and of course reptiles, the dinosaurs as well as the upcoming reptiles. The pteridophytes and conifers plants, they were common in the Cretaceous period, but in the Cretaceous, the flowering plants originated. So these pteridophytes and conifers, they were of Gondwana affinity, while flowering plants, they originated during the Cretaceous period. Okay, now let us see the tectonic evolution. Now, in my previous class, I had told you that the dismemberment of Gondwana land, it started in late Cretaceous, sorry, late Triassic, and it continued to the Cretaceous. So, during the late Jurassic, you can see over here that the initial breakup resulted in separation of India from Antarctica in late Jurassic. So, this was the Antarctica. This is India. There was a breakup between Antarctica and India. And then rifting and separation along the eastern margin of India progressed from northeast to southwest. So I'll just draw for you how this rifting took place. It took place along the eastern margin like this. Like this. I have another diagram to show it to you. Northeast, southwest. So this is how this breakup had started. And this caused the movement of Indian plate northward away from the combined Antarctica and Australia. So this was the portion where the Indian Ocean started to open. So this is the map of early Cretaceous during Hauterivian, while this is just a representative fraction. So you can see here close to 126 million years. You can see this portion over here. This is the opening of Indian Ocean. And why did it open? It opened due to this rifting, which started to separate India from Antarctica, Australia, and this rifting was along the eastern border, eastern margin of Indian subcontinent, and the rifting took place in northeast, southwest direction. So this was the initial phase of rifting. So see, this is the first phase of rifting. What it tells us that India separated from Antarctica and Australia, and this southwest to northeast direction of rifting along the eastern margin of India led to the opening of Indian Ocean. I hope it is clear. So when did this happen? This happened close to Barremian, 127.5 million years. After the first phase of rifting came the second phase of rifting. In the second phase of rifting, an important event occurred due to the Kerguelen hotspot activity. Once I deal with the Deccan Trap stratigraphy, I'll show you the location of all the hotspots on the earth. So due to the Kerguelen hotspot activity, Rajmahal volcanics occurred. So this is the region where the Rajmahal traps are exposed today. Why did this happen? This is because of the plume activity or the hotspot activity. So if you have seen my video on the Wilson cycle, you must have come to know how due to a hotspot activity these volcanic eruptions they take place and how these volcanic islands are formed. Okay. So at close to 118 to 120 million years, the Rajmahal volcanics they were formed because of the Kerguelen hotspot activity. While between 110 to 108 million years, what happened? The Indian plate moved further northward while the this hot spot which led to the formation of Raj Mahal, it uh, separated from the Indian plate and it became a part of the Antarctic plate. So you can see over here that the place where earlier the Raj Mahals were formed in this slide, look here, they became a part of the Antarctica plate and they separated with the Indian plate, separated from the Indian plate, and then they became the Kerguelen Island. And how do we know that it was earlier a part of Indian plate? The Kerguelen rocks, the rocks of Kerguelen Island, they are of the same composition. They are of the same composition to that of the Rajmahal volcanic province. Okay, so it becomes important over here that the you should understand that how did this rifting lead to the formation of the Kerguelen Islands, and when was this? Around 108 million years. Okay, so having said all this, the evolution of the Indian plate, the dismemberment of the Gondwana land, and how Indian plate moved ahead, let us now come to the geological map of the Kaveri Basin or the Tiruchirappalli region. We will go discuss in detail the stratigraphy a bit later, but on the left you can see a table in which you will find the lithostratigraphic succession of the Cretaceous stratigraphy of Tiruchirappalli. So the basement is the crystalline rocks, and these rocks, they are all Precambrian. So in this map, you can see these rocks over here. This is the Archean crystallines, the Precambrian basement. It is unconformably overlain by the Aptian Albian. The Aptian Albian rocks. So when I say Aptian Albian, it means we are talking about the late early Cretaceous. Late early Cretaceous. So the Shiv Ganga beds and Dalmia Purum formation. Okay. They are followed by, they are unconformably overlain by the Uttatar group and Trichinopoly group. So here you can see the this legend and you can correlate the map with these formations. Trichinopoly is further unconformably overlain by the Aryalur group. So Uttatur is divided into Marwatur formation and the Karai formation, while Trichinopoly is Kulakat Nattam formation and Anaipadi formation. Then Aryalur has Silakudi, which is unconformably overlain by Kalan Kurichi formation and Kalamedu formation. Then the Ninur formation and Kadlor sandstone. So if you see here carefully, the light gray, this portion, this one, this one, this one, and this one, these are all the equivalents of the Kadlor formation. Then you have the Ninur formation, which is this. This is the Ninur formation. The Kalamedu formation, this is the Kalmedu formation. Then Ottakovil formation, it is this. So this is how you can correlate the entire map. And so this is the north, and this portion from here, it is the Bay of Bengal. So this is the direction of the coming of sea. Of course, it is not shown in this map, but you have to imagine this, that this portion, the boundary is the coastline, and on the east side of that is the Bay of Bengal, from where the sea comes in. The Cretaceous rocks of Tiruchirappalli, they are exclusively rich in marine fossils, and now you can understand the reason why. If you trace back the history of evolution of the Indian plate, then you can understand the variation in and fluctuations in the sea level. They had led to the marine biota to proliferate, and therefore the Cretaceous rocks, they are rich in marine body fossils. So as I have earlier told you the names, bivalves, gastropods, cephalopods, brachiopods, corals, echinodermates, algae, and microfossils. These are very commonly found in the Cretaceous formations of Trichinopoly. That is why the Kaveri Basin is also known as the Field Museum of Cretaceous Paleontology. And here there are several thousand meters thick clastic as well as carbonate rocks. Okay. And historically, the first studies were started by Stolik Zaka. Stolik Zaka. So the Cretaceous formation, the Cretaceous sequence of Trichinopolli was divided into four divisions. The Uttatur, Trichinopolli, Arialur and Ninur. Okay. First, second, third and fourth. Out of which the Ninur formation does not belong to Cretaceous. It is younger than Cretaceous. Uh, and this classification was done earlier on the basis of lithological characters and fossils. Now the age has been revived and Ninur has been brought into Paleocene, Eocene. So Aptian Albion, that is the late early Cretaceous, it has Sivganga beds, Dalmia Purum formation. Then Cenomanian to early Turonian means the Cenomanian and early Turonian means they are the early late Cretaceous. It has Uttatur group which is further divided into Marvatur formation and the Karai formation. Late Turonian to Santonian means now we are coming to the middle part of late Cretaceous. It has Trichinopolly group which is further divided into Hula-Cat-Nattam formation and Anaipadi formation. All these are unconformably overlain by the Campanian to Maastrichtian. It means that the Santonian to Campanian deposits are missing in Trichinopolly. So the Campanian to Maastrichtian, it has Arialur group, very, very important group, and it is divided into the Silakudi formation, which is unconformably overlain by Kalan-Kuruchi formation and Kalamedu formation. And then after Maastrichtian, the Paleocene Eocene deposits of Ninur formation are there, which are further overlain by the Cuddalore sandstone. Let us now discuss all these one by one. So here you saw that the Precambrian were the crystalline basement rocks. So the Precambrian basement rocks, they are composed of different types of gneisses, charnokites. I hope you all know what is a charnokite. I had discussed with you when I was teaching you the dharvas. Then granulites and allied rocks, which allied rocks which belong to the Precambrian of Eastern Ghats. Eastern Ghats. It was a mobile belt, as I hope you all remember. So all these, they border the western side of the exposed sediments. The Precambrian basement is overlain by the Sivaganga beds. Its age is thought to be the Upper Gondwana age. But you all have seen here that it is the late early Cretaceous. It has affinity to the Upper Gondwana rocks. Now, the Sivganga bed is a locally exposed bed. It's not very thick, hardly tens of meters thick, and it has dominant clastic lithology. It has sands with shale intercalations. Shale intercalations. These are all shallow marine regressive deposits. Shallow marine regressive deposits. The sediments over here, they are not richly fossiliferous. They are poorly fossiliferous, lesser number of fossils. And the fossils which are present, they are of bivalves, gastropods, and interestingly, they have yielded tylophyllum fossils. So, tylophyllum, and then the age is late early Cretaceous, Aptian Albian. So, the Shivganga beds, they are considered as one of the youngest representatives of Upper Gondwana in India. You should remember this. It's a very important point. It is the youngest representative of Upper Gondwana in India. Okay, so this is the Shivganga bed. Next comes the Dalmia Purum Formation. The Dalmia Purum Formation, it comprises of limestone, marl, grey, shale. All these are fine textured sediments. Okay, so previously the coarse sediments were there, and since these are all fine textured sediments, so they indicate increasing bathymetry. Increasing bathymetry. Bryozoa, algae, microplanktons, all these are the common microfossils in the Dalmiapuram formation. The lithology and these fossils over here, they suggest slack water, means quiet water conditions over here. And the age is given as late, early Cretaceous. As I had told you in that table, the age is Aptian Albian. Now, comes the Upper Cretaceous, which is entirely marine deposit. The marine condition in the basin, they started during Albian Cenomanian times. And why did this happen? This happened because during the Albian Cenomanian time, the rifting of India and Antarctica was complete. So let me come back to that map. I don't know where that map is. Yeah. So once the rifting between India and Antarctica was completed, the sea encroached from the northeastern side. And once this came from this northeast direction, it led to the deposition of the marine deposits. This transgression is marked as an unconformity at the base of Upper Cretaceous sequence. So the base of Upper Cretaceous sequence, this The Upper Cretaceous sequence, this is marked by an unconformity, which basically is the transgression, okay, of the sea from the northeast directions. So the Upper Cretaceous is divided into Uttatur group, Trichinopoly group, and the Arialur group. So the Uttatur group, it is named after the Uttatur village, and it is restricted to the southwestern part of the Kaveri basin. It unconformably overlies the Sivganga beds. Okay, here Uttatur unconformably overlies the Sivganga beds in the southwestern part of the Kaveri basin. The sediments are sin rift in origin. Sin rift in origin. Uttatur group is divided into two formations. The lower one is known as Marvatur formation, while the upper one is known as Karai formation. The Marvatur formation is further divided into three members, the lower, middle, and upper member. Now, the lower member consists of conglomerates with pebbles of basement rock. Okay. The lower member consists of conglomerates with pebbles of basement rock. Means it is an erosional unconformity, these pebbles which are over there. The middle member, it is thin bedded, and it has friable fossiliferous gray shales. Gray shales are over here, and pyrite crystals are also present. Pyrite crystals. This gray shale, it is the fossiliferous deposit. Then the upper member, it is pink to white, dark gray, hard and compact limestone, which has reef deposits and lot of marine fossils in it. After the Marvatur formation comes the Karai formation. The Karai formation, it conformably overlays the Marvatur, means it is a continuous formation. It is dominantly argillaceous. So if sometimes you get terminology like Karai shale, so don't worry, it's okay. It is dominantly argillaceous, and it consists of gypsum bearing shales, silty clays, thin bands of calcareous sandstone and marlstones, and lot of calcareous, ferruginous and phosphatic nodules are present over here. The Karai formation, it bears the fossils of gastropods, so it is also fossiliferous. And the common fossils in the Uttatur group as a whole, they are the gastropods, bivalves, cephalopods, corals, foraminifera, ostracoda, algae, and interestingly, lot of ichnofossils. The Uttatur group has been thought to be deposited under coastal to shallow marine conditions. And the age is Cenomanian to lower Turonian. And this age is for the entire Uttatur group. Okay, Cenomanian to lower Turonian or early Turonian. Next comes the Trichinopoly group. It is also restricted to the southwest part of the Kaveri basin and it is more enriched in carbonate as compared to the Uttatur group. The Uttatur group is underlying group and which consists more of the clastic deposits, while the Trichinopoli group it consists of more of carbonate deposits. Apart from the carbonates, there are irregularly bedded sands and clays. Then Coquina limestone, calcareous grit and conglomerates are also present. A Coquina limestone is a type of limestone which is formed entirely of fossils. The Trichinopoli group is further divided into two formations. The lower one is Kula-Cat-Nattam formation. The Kula-Cat-Nattam formation is also known as the Garud-Mangalam formation. So you can remember this name. Garud-Mangalam formation. The Garud-Mangalam formation, it has bands of conglomerate at the base, followed by hard calcareous sandstones, fossiliferous limestone, clay, and siltstone. So here the Garud Mangalam has a lot of these calcareous deposits, while the Garud Mangalam is overlain by the Anai Padi formation. The Garud Mangalam formation has three members, lower, middle, and upper member, while the Anai Padi formation it has two formations, lower and upper. Anai Padi has two lower and the Trichinopoli group, it is less fossiliferous than the underlying Uttatur and overlying Aryalur. These are all littoral deposits, means very close to the shelf. Oh, sorry, littoral. Littoral. Littoral deposits. Fossils, gastropods, mollusca fossils means gastropod, cephalopod, pelecypod. Then corals, brachiopod, echinoids, and foraminifera. And the age of the Trichinopoli is late Turonian to early Santonian. Then comes the Aryalur group. Aryalur is a town and it has been named on the basis of the Aryalur town. It is most extensive and most fossiliferous. It unconformably overlies the Trichinopoly group, as I had already explained. This is more sandy. Okay, the Aryalur group, it is more sandy, more clastic material, and it has more uniform beds. In previous ones, you saw irregular beds. Here, the beds are uniform beds, more uniformly bedded than the Uttatur and Trishna groups. Aryalur is divided into three formations. The lower one is Silakudi Formation. Silakudi Formation has two members, lower and upper. And the lower member, it is the lithology is limestone and calcareous sandstone, while the upper one is sandstone, calcareous and argillaceous rocks. After Silakudi Formation comes the Kalan-Kuruchi Formation. The Kalan-Kuruchi Formation, it is dominantly a limestone deposit. And this limestone is ferruginous at some places. The last formation of the Aryalur group is the Kalamedu Formation. Kallamedu, Kalamedu Formation. The Kalamedu Formation, it has arenaceous sediments which is fine to coarse grained micaceous sandstones. Okay, so arenaceous sediments, normally the sandstones which are fine to coarse grained and have mica in them. Aryalur fauna is quite rich and diverse, and gastropoda and pelecypoda are the most dominant fossils found in the Aryalur group. Apart from it, some cephalopods, foraminifera are also found in quite good amount. The age has been given as late Campanian to Maastrichtian. Okay, so I am not discussing Ninur over here because, as I have told you, that the Ninur formation has been included in the Paleocene. So for the Cretaceous, it comes till the Aryalur group. Okay, so what did we see over here? That the Shiv Ganga bed, Dalmia Purum formation, then Uttatur group, Trishna group, and Aryalur group. These rock formations, they define the Cretaceous stratigraphy of the Trishnapalli region or the Kaveri basin. So this completes the Cretaceous of Trishnapalli.